Hello, everybody, and official warm welcome. Welcome to those of you who are already on campus. Some of you have already been lucky to meet in person. Welcome to those joining now live for this session, and welcome to those of you who are watching this as a recorded session later. The idea here is that we have a short time together for me to give you some idea about the physics course here at UWC and what it's all about, who is teaching it, how is it being taught, and why should you choose physics, or perhaps why you should not choose physics. I can talk for hours about the content of the course. After all, I can teach the whole thing over 2 years. I could go in depth with a lot of details about curriculum, what's in there and what's not, about all the specific details about how the exam works, and all of that, and make it very boring very quickly. But I would rather try to talk a little bit about what is physics. We will also have a look at least an overview of what's the contents of this course. And then I'll talk a little bit more about, so how will we teach the physics course here? As you are well aware, this school year is starting very differently compared to many other normal school years. So we will also start this course in a slightly different way, which should support everyone, whether you're on campus or not, and which should allow you all to learn as much as you possibly can, hopefully while having some fun. Okay, so while I'm doing this, if you have any questions, feel free to write them in the chat, and I'll see if we can fit them in at the end. If you are not watching this live, please feel free to send me an email, or even if you are watching this live, if you have any questions, any uncertainties about the course, about physics, something that you would like me to elaborate on or know more about, please just write me an email and I'm happy to reply, or write in the chat and I will try to answer it right away if there's time for that. Okay, so before talking more about physics, I'll give you a short introduction to myself and my colleague. He will join us in a moment to give an introduction of who he is. So my name is Stefan. I am originally from Denmark, where I have lived most of my life. I've studied engineering, and after I spent some years at university studying, I worked in research for several years actually, doing research in micro and nanotechnology. And after having done that for some years, I decided it would be fun to start teaching. I've been teaching now IB physics for the past 6 years, so this will be my 7th year. And so far, that has been a lot of fun. I joined UWC in Dilijan 1 year ago, so this is my 2nd year teaching here. And with me, I have my wife and our 2 kids. When I'm not teaching physics, I'm the tune parent of Axtev. So that's also part of my job here. So that's just a very short introduction to my background. Assisting me or helping me out in teaching physics this year, for the first time, we have Levon, and I would like Levon is sitting right over here next to me, so he'll come and say a few words about who he is.
Hello everyone, welcome to UWC Dilijan. I will happy to see you face to face. So my name is Levon. I'm originally from Armenia. I was born in Dilijan. I have studied microwave physics. I have my master degree. Also right now I'm doing my PhD and I'm student. I have involved in many research areas in microwave physics. I'm doing some kind of wireless sensors research or different visualization systems of electromagnetic waves. So I have joined this school last year as a lab technician. I'm also working in this school in the science labs. You will see me if you will choose chemistry or biology. And this year I'm joining to Stefan for teaching you physics. I will help Stefan to teach you, and I will be a teacher assistant. I'm really happy to see you all.
Thank you, Levon. We are currently not at the same state. I am wearing one of the green bracelets, and Levant is red because he is not living on campus. So that's why we are also observing a little extra social distancing here. Before I sit down again, I just want to adjust this a little bit to show you that right now we are sitting in one of the physics labs, physics classrooms. So I'm hoping before too long to have you guys all join here in the classroom. Typically, of course, there would be students sitting behind where I'm sitting now, and there's, as you can see in the background, a board and a very classic classroom. We also have some work tables, and we have a lot of nice equipment for when we are doing practical work. Part of this course is once in a while doing exercises, getting our hands on some physics. Sometimes our experiments can be partly virtual or online and partly using real life equipment. Again, that has to do with what we can and where we are. At the beginning, everything we do will have to be online. Later on, I hope to have the majority of you here with us in person, and of course there's some different things we can do. But as long as we still have some students who are not physically with us or who are still in quarantine, of course we will make sure to teach the course in a way that supports everyone. So speaking of that, I mentioned that I have been teaching this course for the past 6 years. I know the content pretty well. I have a lot of materials that I would usually use. I typically, in a teaching lesson, I would often be standing at the front for part of the lesson. I have some PowerPoints that I would be using. I have some worksheets that I might print out or send to my students to work on. I have certain exercises and ways of doing things. And like with a lot of other things, a few months ago, everything had to change. I'm sure you've all experienced that in your previous schools. You're well aware of the situation right now, how hard it's been for many people to get to Armenia, why we're not doing regular classes, and so on. So for this year, I'm going to try something which will be new for me and new for you as well, I presume. Starting, we know for a fact that when we start this course, not all students will be on campus. Not everyone will be able to participate in a live lesson because some might be in a very different time zone, have a poor internet connection, or some other issue that makes it impossible for them to attend. We want to make sure that we can support everyone. So this year, the course, instead of being a very much teacher-led and teacher-guided course, I'm going to try a model that I will call assisted self-study. This is not new. It's not something that I'm just making up, but it's the first time I'm trying to teach the course in this way. And to support us in that, we're lucky here at our school that we have a subscription to an online service, which I would like to show you now. So in a moment, hopefully on your screen, you will see what I have on my screen. This is a page, as it says in the top, called In Thinking. It also says student pages at Think IB. This is what it looks like to a student entering this page. I have made a test student, so this is why this is what you would see if you were to enter this site once you've been given a username and so on. And this student is having so far only one subject in here, which is IB Physics, and I am their teacher. They already have some active tasks waiting for them over here, and then they can join in. They might have other subjects in here as well, but right now it's only showing physics. And here they kind of get to the front page of the physics course. So in here, there's a menu both at the top and down the side, which has a lot of different content. I will not go through all of that now because it's essentially the whole course that's in there. But I will in a moment share with you kind of an overview of what this is like. So when I say that I want to teach this course as an assisted self-study, what I mean is instead of many lessons, especially at the beginning of the course where I'm standing at the front talking to whoever is able to be in the classroom, and then having to find a way of supporting those who are not in the classroom, we will try our best to support everyone in learning through this profile, through this page, not only through this page, but based around this page. We have physical books for those of you who are here, different physics books. We have another online physics book that we can give you access to, especially if you're still back home. So there's lots of resources available. The reason I would like to use this page is that it allows me to set assignments for you guys to work on and give you deadlines, and then it allows me to keep track of how far you've been doing, how much time you've spent on things, and whenever you're answering questions, quizzes, and so on, I can get an overview of how you're doing. So what I expect to happen is that we start lessons next week online fully, because we're not allowed to all be here in the classroom together yet. In those first couple of lessons, I will be here with you, and I will be setting assignments for you to work on. So if you're there live for our lessons, you will be sitting at your computer working on this. If you're in a different time zone, you may not be able to be there live while it happens, but you can work through the content as part of the class on the same page at your own time. And I'll make sure that there's enough of a deadline so everyone will have a reasonable time to work on it, no matter where in the world you are. The fact that all the content is here, or most of the content is here from the very beginning, means that if some of you are getting a little bit bored or you want to read ahead, you can always study more. The whole course is already there. There might be certain pages that I will assign for you to read, or there might be certain other tests or assignments that you won't see from the beginning, but that we can send to you along the way. In addition to this, sometimes we may have a worksheet, an assignment, or something else that is not in this system. So in parallel to the in-thinking side, we'll be running a Google Classroom. Some of you will have met that before. Some of you will be completely new to it. But Google Classroom is essentially another page where you will all be invited as users with the rest of your class. I can write something as a teacher and you'll all see it. I can upload materials. You can work on some assignments and upload your answers there. So it's doing many of the same things that the in-thinking side is doing. It's just also supporting other materials that was already in here. One of the reasons I'm actually quite excited to start using in-thinking is the name up here. This website is written by Chris Hamper and Emma Mitchell. Chris Hamper has been teaching IB physics for very many years, and he is currently the IB physics teacher at our sister school, UWC Red Cross Norway. And he's been teaching this course fully online for the past several years. So the model that I'm just talking about now with assisted self-study is not something brand new. It's actually been tried and tested over several years. And the way it works in practice when we get to go to the classroom is that I will still assign stuff for you to work on. When we come to the classroom, I will probably have a short introduction. Today we're working on this. I might do a short little teaching. I might show a few slides and say this is kind of the main content, or I might follow up on something from a previous lesson. But the majority of the time you will be working alone or in pairs or in small groups, working through the content at your own pace. When we're starting online, that will happen wherever you are. When we're actually allowed to physically be together in the classroom, of course, that will happen when your schedule says physics and when you're in the classroom. But you will still be working on the stuff through the content on your own with a teacher around. That's the nice thing about this. When you're in the classroom, I will be here, all the one will be here. We will know the content, we will be able to help you. And I know this might take some getting used to on your behalf. It might take some getting used to on my behalf. But I think once we get used to it, the majority of you will actually learn more and learn better by working through things on your own time. If there's something that's really tricky, you're really struggling with, you can spend more time on that. If there's something where you need extra help, well, you can find us and you can write a question, or you can ask a question. If some people have got things completely under control, that gives me more time to help those who need more help. So this allows for people to work at slightly different pace and for all of you to get as much out of the course as you possibly can. One thing that this requires is responsibility. I know you're just getting here. You're only now, for very many of you, moving to a completely different country, maybe starting to receive lessons in English for the first time, which is for many of you a second language or even a third one. Having to get to know new people, a new way of school, a new way of life. So it can be overwhelming to also have to do this. I am still the teacher. Levon is still the teacher. We are still responsible for your learning. Your responsibility is to actually be here, be active, pay attention, and kind of stay on top of things. And most of all, and that's what might take some adjustment, your responsibility is to make sure to let me know when there's something you're not getting, when there's something that's difficult, you're falling behind, or you're having a hard time with this. Then I need to know so I can help you. So the responsibility of me and of the teachers is to keep an eye on your progression and keep an eye on how you're doing. Your responsibility as student will be to make sure to work and to let us know what you're struggling with. Why physics instead of all kinds of other subjects? Well, of course, I teach physics because I love it. I really like the subject, and I think it's super interesting. So maybe if I start there before going into a little bit more detail about the content. I really like physics because to me, physics helps me answer some of the really big questions about our world. Physics deals with anything from the tiniest building blocks of everything to the largest scales and the largest elements in our universe. Throughout the 2-year course, we will be looking at atoms and molecules and tiny things, all the way through to galaxies and black holes and big things in space. Physics attempts to explain how the world works, explain some concept. And why I personally like physics is because we start somewhere where I can understand things from an everyday experience. A lot of the content can be explained using everyday things. If you talk to some of my students from last year who know me, they will tell you that I'll very often be having some everyday object. I'm sitting here in front of me, happens to be a kettle because I like coffee. Well, there's a lot of good physics in a kettle. How does water boil? What does it mean? What can we do with the hot water? I very often grab some object to explain something, and I can do that because it's physics. If we talk about forces, well, we can take any two random objects and we can start talking about what happens. And we start with something that we've all experienced. You've all at some point in your life been throwing around a ball, or been running really fast, or been trying to push something very heavy. And so there's a lot of kind of intuitive understanding of a lot of the things we start with. We can start with something we already understand. We might not have learned in school how this thing works, but we understand it because it deals with our everyday world, our everyday life and the world around us. And that's one of the reasons why I really like physics. It helps us understand the bigger picture. How does the world work? Why does the world work the way it does? At the same time, physics is sometimes challenging. Some people will find it very difficult, some parts of the content. I can almost guarantee that over 2 years of studying physics, all of you will encounter something that is difficult. It has to be challenging because otherwise you wouldn't be learning. But of course, we have to find the right level of challenge. Physics is spoken sometimes in a very technical language, or we use a lot of special words, and sometimes words that mean one thing in everyday language means something slightly different in physics, or two words that can mean almost the same in everyday language does not mean the exact same in physics. There's actually an important distinction between them. Just one short example is in your everyday language, you might be seeing someone going by and you'll say, that's a high speed. Or you might be saying he's going at a high velocity. And in everyday language, the words speed and velocity are kind of synonyms and they pretty much mean the same thing. But in physics, there's an important distinction between them. They both, to some extent, represent the same, but there's a slight difference. That slight difference is actually a mathematical one. And that's kind of one more important truth. The main language of physics. Physics can be spoken in many languages. We're teaching it in English. You might be used to physics in a different language from back home. But the universal language of physics, that's actually math. In physics, a lot of what we do starts with trying to understand something we experience in everyday life. We look at throwing a ball and we try to predict where it will land. And then we try to come up with a rule, with a law. If I throw it at this angle, this hard, how can I predict where it will land? Well, if I understand the laws of what affect it, when it's in the air, what causes it to come back down? What are the forces or things that are affecting it? If I can understand those things and I can write up an equation to describe it, in the end, I can solve the equation and I can calculate where will that ball land, for example. So the way we communicate and the way we work with physics is actually very often by solving math. We use a lot of equations. In your math classes, you might be used to lots of numbers. We also have those. But very often we start with words or with letters to represent different variables, different things. So only once we have kind of started understanding the general rule, we then look at the specific problem. This ball is a tennis ball. It's that big. It weighs this much. And we're throwing it that hard. So using the specific numbers and the specific values, we can finally get to the point where we can actually solve our equation. This, of course, means that to be a very strong physics student, you also need to be a fairly strong math student. Physics is for everyone to some extent, but if you want to do really good in physics, you also have to be able to do quite good in math. That's not a requirement that in order to do physics, you have to do high-level math. But if you would be struggling in standard level math, you will definitely also be struggling in physics. So it's a good idea to, at this beginning of the course, when you have to decide which class to take, to think back. This does not mean that if you think I'm sometimes having a hard time in math, then you definitely shouldn't do physics. But it's a lot of the same skills that are needed for the two courses. I have already spoken to some of you, and I've heard more than one student say, oh, I really like science. I would like to do bio and chemistry and physics. I would like to do all of them, or at least two. It's not possible within the constraints of the IB and the timetables to actually do all three sciences, or there's even ESS, which is also hard science at least. First of all, it's not, like I said, in terms of timetables, possible to do all of them. And second of all, we will very strongly encourage you to not do two sciences, or at least not to do two high-level sciences. Many of you, if you're strong in science, if you're already good at chemistry or biology, or you really want to learn more of any of these sciences, I understand that you would really like to do two. We do have students doing two sciences, but for most people, that is too big of a mouthful. That's too much at the same time if you want to do good in both of them. So at least I would encourage you to be very thoughtful, think a lot about this. And then I can see that might raise a question. So if I can only do one, or if I should only do one, which one? And there's not one definite answer for each of you. If you're in doubt, if you are wondering, so is physics for me, or should I rather do chemistry or biology? Let's have a talk. Send me an email, and let's have an individual talk to figure out why you prefer one over the other, or why you're in doubt. Then that way we can help you make the right decision. These taster lessons are all about helping you decide on the right subjects to get started as good as you possibly can, and then of course move on as well as you possibly can. I promised I'll get a little bit more into the content of the course. Time is running. Some of you will have already been thinking, wow, he sure can talk. And yes, I am one of those teachers who can talk your head off until you fall asleep, and I'm trying not to. That's just one of the reasons why I think this assisted self-study will be really good for you as well as for me. I try not to be too self-absorbed. One of the things that my students often need to learn, especially in a school like this, where you're from very many different cultures and different schools, is that I like to be informal and I like to be on the same level as you. I much prefer if you'll just call me Stefan. Refer to me by my first name and we can have a very normal conversation. Sometimes students find it very uncomfortable not to call me Sir or Mr. Johansson or something like that. And if that's what you've been used to, of course, I will not say you can't do it, but I like to be face to face as much as I can with you guys. When we start doing in-person classes, I hope we will soon develop an environment in class where it's perfectly okay to ask a question, where it's perfectly okay to be in doubt. I always tell my students from the very beginning to please point out when I make mistakes, because I do. Part of learning is making mistakes. In my life experience, the biggest lessons come from making mistakes. And when working with a difficult subject, such as physics sometimes is, you learn through mistakes. That's why we'll try to give you lots of exercise, lots of assignments, lots of exercise to work with the content. Because when you get the answer wrong the first time and you work a bit more with it, you figure out why it was wrong the first time and how to get it right the second time. You might have to ask a teacher, you might have to ask a classmate, but when you get it right, you have learned. If you don't allow yourself to make the mistakes, then you won't learn. If you don't allow me to know that you make the mistakes, then I can't help you. And my job is to help you. So there's no shame in getting an answer wrong. There's no shame in not understanding things the first time, because that's part of the learning process. Okay, so just have a short look at the content of the course. I know from the very beginning, some of you will already be thinking, what about exams? What's going to happen? And yes, at the end of the course, there is an exam. And I'm happy to, at some point later on, go through all the specific details. For now, I'll just tell you, on a normal year, there are 3 exams at the end of the physics course, 3 papers. One is all filled with multiple choice questions. One is what we call open questions, which cover most of the content, where you will be presented with some problem and you will have to figure out what is the right approach, what is the right equation, and how do I solve the problem. And the last paper is dealing with some things you have learned from practical work, from being in the lab, and then it deals with an option. There are 4 options, and we have to choose one of them. You don't necessarily all have to study the same option, but that's towards the end of the course, some of the content where you will study one topic a little bit more in depth, and the last exam paper is on that. There's one big assignment throughout the course that you have to hand in, called the internal assessment, or IA for short. Some of you will already have heard a lot about IAs in different subjects. In physics, there's one, which means that at some point during the 2 years, you will be performing a piece of physics work on your own. The vast majority of students end up doing an experiment of some sort. You think of something that you want to know more about. We help you select something suitable. You design an experiment, do the experiment, and then you get some data which you analyze. You make some graphs or you make some calculations, and you learn something from the experiment, which finally you put in a report. That report will be graded by your teachers, and the final grade will be sent off to the IB, and it counts for 20% of your final grade. The remaining 80% are determined by that final exam, those 3 exam papers I talked about. So what is in the course? As you can see here, there's a tab on this page called Online Course. That's a lot of content for teaching this online, which could very well be relevant if we have some of you still at home when we start teaching. There's a lot of exercises that you can do at your home with everyday things you have around. So if we have to do some kind of an experiment, there are lots of ways they can be done at home with stuff you might have in your kitchen or in your room. ways to help you do this, or there could be some simulation, some virtual experiment you're doing on the screen. Then there's the standard level core and the additional higher level. I'm sure you're all aware that this courses in the IB are taught at either standard level or higher level. And we have so far in physics been running with combined classes, which means that in a physics class, there will typically be quite a lot of students doing the high level course, and some students doing the standard level. The fact that this is core means that we can actually think of it as the center of the course. The core is what everyone needs to learn. If we look at it, just to give you a short overview, there's something about measurements, something about mechanics, thermal physics, and waves. We'll not go into a lot of details with all these now. We can spend lots of time on that later on. We will learn something about electricity and magnetism. We will learn about circular motion and gravitation. We will dive into atomic, nuclear, and particle physics, and we will learn about energy production. So these are 8 topics, 8 chapters. They are here ordered from 1 through 8. The official IB guide to the physics course states exactly what's supposed to be in the course, and it has these exact 8 in this order. So like I said, this webpage is written specifically to support you in going through the IB physics course. For everyone who's doing physics, within 2 years, we'll have covered all of this. We will have done an internal assessment, and we will have done one of 4 options. Here you can see the options: relativity, engineering physics, imaging, or astrophysics. Each of you will have done one of those. You may work together. You may be super interested in wanting to do more than one, but in class, we will typically cover one. And then sometimes we have students who want to study another one on their own time, or a second one, and we're happy to support you in that. Each of these options have a core, and then they also have additional higher level material. So those doing physics at higher level, they will study everything in the core, they'll study one of the options, and they will study the higher level portion of the option. In addition to that, they will study additional higher level material. Here you will see there's one chapter called wave phenomena. When you have studied the chapter or the content of waves, you can go more in depth and learn more about it, and that's covered in wave phenomena. When you've learned about electricity and you've learned about gravitation, you can learn more about the concept of fields. It has to do with magnetism a bit as well. And fields is a concept that's difficult to explain in a few words, but once we are starting to work with these things, we'll start talking a lot about fields. And then we can go even more in depth with the fields when we go to chapter 10. So if these are 1 through 8, then this is 9, 10, 11, and 12. Electromagnetic induction also deals with more magnetism. And finally, when we've studied atomic, nuclear, and particle physics, we can go even more in depth and do quantum and nuclear physics here as well. So the way the course is usually taught is these things do not come completely in order. We will typically start with chapters 1 and 2, kind of combine them a little bit together, and then after a couple of months, or how long that takes, I will start teaching waves. You will learn about waves, because then those who are doing the higher level portion, they can already learn a bit of the higher level material as soon as we've covered that. And similarly, the rest of the course is structured in a way to make sure that we have everyone doing some of the core material, and then we have some time in between. So we might do core studying the first couple of chapters for the first 2.5, maybe even 3 months of the course. But then we will have some weeks where we do higher level material. And that means if you're doing physics at standard level, there will be a few weeks where you will not have regular classes. You might be given a bit of extra practice exercises and so on, and you might simply have some lessons throughout the week where you are free to do other stuff, to work on your homework from other classes and so on, because the physics classes will be working on high level material. We may also simply now this year when we're doing this online and this assisted self-study, we might have some of you get to the higher level material faster than others, and then you can work on that on your own time, of course. So just to show once again, if I go back to the dashboard of this test student, I can see that I have a bunch of active tasks. There's some deadlines here. Those are both in my physics class because this test student only has a physics class. One of them is a test, and one of them is a writing assignment where he or she has to write something. If I click the writing assignment, I can see here the instructions. They are not too long because I've just made this for showing you now. Please explain in your own words something, and then you're asked to write somewhere here. It says 50 to 250 words. You can write them, your own answer, and you can submit the task. We can also go out here to see what tasks are there. Well, the current tasks is this one on accuracy and precision. There's another one which is a test. And finally, I'll just go back home. There's a completed task. This student already did some reading. So this is the first activity that this student has been doing. It says here, as you can see, you've already submitted this task to your teacher, but feel free to do it again. So this one was assigned and this student already did it. There's some instructions. This is a simple one. Please read the pages and solve the tests. Then there's some reading. You can see here there's some support for doing this at home. It's a small experiment that you can do in class. If you're not in class, you can do it at home using a potato and a ruler, something as simple as that. So things that you are likely to find in or around your house. There might be some interactive content here. So sometimes this one we're learning how to use what's not called the vernier caliper. And you can actually play around with it and you can see if you read off the value correctly, and then you can double check whether you got it right. So that's one of the purposes of this particular exercise. And when you've read this and solved this, this one also has you doing some work in Microsoft Excel or Google Sheets to actually learn how to collect some numbers and how to do different analysis. This is something we'll probably do quite early on in the course. This step-by-step takes you through, shows you how you can solve this. And when you've finally done this on your own time, there might be a video to help you out, how to solve this, how to interpret your results. You can click complete. Now this student already did that. There might be some extra problems and an extra quiz you can do. So this is just one page. Of course, there are very, very many of these. We will assign them in a way that I would typically assign what you need to do at least some time in advance. For as long as we're doing this course online, that means that you may know what you're supposed to do within the next week, because you may be on campus and doing it at the same time as most of the others, or you may be back home in a different time zone and doing it at another time. And as long as you finish by the stated deadline, you're good to go. When you do this and you actually submit it, then of course when I log in as a teacher, I can see the overview of the class. I can see who has done this, how much time did they spend on it, did they get the questions right the first time, or are there some of them that they were struggling with? And that helps me help you, because next time we get together, I can say, okay, so this particular question, I noticed quite a few of you had a hard time. Let me just do it on the board for you. I hope overall this makes sense. I know I have been talking nonstop for some time now. I'm just looking at my notes. I think I have covered pretty much what I was hoping to do in this short intro. I would like to ask right now if there are any immediate questions to this. And maybe while you think about that, I will state once again, if you are in doubt about some of this, if you feel that you need to know a bit more, or if there's some question you would like to ask, but maybe just not right now in front of everyone, then feel free to write me an email and I'll get back to you. The whole purpose here is to help you make the right decision. I hope for many of you, physics is the right decision. But if you're not sure, let's have a talk about it and find out. We want you to
Stefan, I have a question. So your everything was like good. Yeah, thank you for the introduction to physics. So you mentioned that you were an engineer, and I have a question. Like, do you have on it? Wait a second. Um, I forgot the word. Sorry. Um,
If you speak Armenian, I'm sure Levon will help me translate, if that helps.
Kapvat, in any way, like Levon, how is Kapvat in English?
Connected.
Yeah, are you in any way connected to robotics tests or that kind of?
Yes, last year I was actually supervising the robotics class, and I hope to also do that this year.
Oh, okay. Thank you.
That's a lot of fun. Do we have a test to pass, or is a certain level required? No. From the beginning, there's not a particular test. I know you've been doing an English test this morning, and you will have a math test tomorrow. What I did say at the beginning or early on was that a good skill or a required skill in physics is math. So if you are struggling a lot in your math test tomorrow, that could be a sign that you should consider whether physics was for you. But if you're in doubt, let's have a talk. Yes. We'll be playing with Legos. I would love to. We'll be using simulators for some practical assignments. Yes, probably. The web page that I've shown you here has some built-in simulations, and you mentioned one, PHET. That's a University of Colorado, makes some really nice simulations, which we can do for different. Some of them we need to do if we want to do, when we learn about nuclear physics, it would be great to have a nuclear reactor to do some experiment, but it probably wouldn't be safe and it definitely wouldn't be legal. So there are some
I have a question.
Alexander, you have another question?
Yeah. So like I have some kind of background in physics, like, but I haven't had any kind of physics activity for like past 3 years. So like I don't remember anything. But I know that like I was pretty good like in 10th or 10th grade. So like what would you suggest? Like if will it be fine for me like to take physics like in HL?
I think that, I mean, of course, without knowing you that good, it's difficult to say exactly if HL or SL is right for you. I would suggest you start, and we'll get to know each other, and we'll find out. As much as possible, we're trying to help you guys get the right combination of subjects at the beginning. But if we have someone who starts doing higher level and then realize maybe that was too much, it's typically possible to make some amendments along the way. If you think physics are for you, I think you should start. And
yeah, I will.
For most of
definitely, I will definitely. Thank you.
If you're really interested in one of the options, will we be able to learn it? So if you're talking about these 4 options that I showed over here, we will definitely be doing one of them. All of you will be doing one of them, and it's also possible to learn one of the others. There will be some amount of teacher support available. Now we're running out of time, so I'll have to wrap this up because these lessons can't be too long. But what I have been doing and what I hope to do again is, as soon as we are in class, having at least one weekly support session, which we call physics tutoring. Essentially, one afternoon where one of us will be present in the classroom and people can drop in with any kind of problems, questions, homework, dealing with physics. And that will also be a good time if you want to study an extra option or you want to have some extra assignments, then that's the place to go to. In the beginning, when we do this online, we will probably also, I will assign things for you to work on during the week. And if I learn that there are some people studying from a very different time zone, I will also try to be available maybe at night Armenian time or in the morning, 1 day per week, for someone to come and to ask questions, even if our regular class lessons are in the middle of the night for them. So before summer, when we were teaching the course online for some weeks, we did exactly that. I would have 1 day per week where I would be online in the morning Armenian time, and again 12 hours later in the evening, so that there was always, we called this a drop-in session. So a time where anyone could come by in a virtual classroom and ask questions. We're here to support you, and we'll definitely make that happen. All right. I'm afraid I'll have to stop the recording. I'll just do that so that it doesn't get too long.